Okay, I'm going to start with number 1 for the review. If you guys look at number 1, the one thing you do not want to do is you do not want to distribute the power into the power. Okay, that is not acceptable. You cannot distribute an exponent when there's a plus or minus sign. Think about this up here, x plus 2 squared. You know for sure that you have to FOIL that. You cannot just say x squared plus 4. We don't do anything with the third power, third roots. We just leave it the way it is. So the only thing we can really do here is we can rewrite the top as the third root of 2x cubed plus y cubed. That stays the way it is. And then down here I have 3 and then the 2. Well, I have 1 2. I need 2 more 2's so I can break that radical symbol. So I can say that I'm going to multiply the top and the bottom by the third root of 2 squared, which we all know is 4. I'll rewrite it with that right now. So third root of 2 squared times third root of 2 squared. Now, one thing you can't do though is we're multiplying, and since these are both third roots, you can multiply this number in right here. You can multiply it into both pieces. So what happens is you get 2 squared, which is 4. So 4 times 2x cubed is 8x cubed. We still have the cube root plus 4y cubed. And then all over, this turns just into 2. And that's the final simplified answer for this problem. Okay, that was number 1. Number 5 was the next one that people had questions on. Again, I cannot stress this enough. For number 5 or any problem like this, first thing you do is break down the base numbers to the most common factors. So for instance, 20 I know is 2 times 5, or 2 squared times 5 I should say. I'm going to put that to the 7/8. Times 15 is 5 times 3, and that's all to the 5/8. And then all over, 6 turns into 3 times 2 to the 1/2. Now, you can, in this case, distribute the exponent, or multiply power to a power. This is 5 to the first, 5 to the first, 3 to the first, 3 to the first, 2 to the first. Because there is no plus or minus sign at all. So you can power to a power, you can multiply. So this turns into 2 to the 2 times 7/8 is 14/8. 5 to the 7/8 times 5 to the 5/8 times 3 to the 5/8. Okay? So we have 2 to the 14/8, 5 to the 7/8, 5 to the 5/8, 3 to the 5/8, all over 3 to the 1/2 times 2 to the 1/2. Now, before you guys think about rationalizing, which sometimes you do have to rationalize, double check to see if you have any common base numbers. So right now I can see that I have common base numbers here, and I can divide these. When you divide the same base, you subtract the exponents. Same thing with these over here. I have 2 to the 14/8 over 2 to the 1/2. So I'll do that one first. 2 to the 14/8 over 2 to the 1/2. Turn this into eighths. This turns into 4/8 if you want to change the fraction. So 14/8 over 4/8 is 2 to the 10/8 on top. Next we have 5 to the 7/8 and 5 to the 5/8. That turns into 5 to the 12/8. And finally, we can also change this one down here to 4/8. Put it over here. This exponent here is 4/8. So we have 5/8 over 4/8 is 1/8. So we get 3 to the 1/8. And there's nothing left on the bottom here. Nothing left on the bottom here. So now all I have to do is I have to write it in radical form and take out any numbers that I have that are higher than 1. So 10/8, there's going to be a 2 outside. There's going to be 1 2 outside. 5 to the 12/8, that means there's going to be a 5 outside. And then on the inside I have the 8th root of, well, I used 8 of the 2's to take it out, so I have 2 squared left. I used 8 of the 5's, so I have 4 of those left. And then 3, there was not enough to take out, so I'm times 3. And then if you multiply that all out, 4 times 5 to the 4th times 3, you should get 7,500. Usually I say 4 spots would be better or appropriate, but if you can get here or here, I'd at least simplify the outside number. This is the most exact answer though. Okay, let's go on to number 17. Number 17 was the next one that people had questions on. And then 19. So, what is f inverse of x if f of x is x squared? So, first thing you do is, well, first of all you guys should know that this is, looks like this. It's a parabola. Okay. Oh, that was a bad one. What is the f inverse? Well, since this is both pieces of x squared, I'm looking at both pieces because it's y equals x squared. So y equals x squared. To find the inverse, you switch the letters. X equals y squared. And then solve for y. Y equals this plus or minus the square root of x. We need both pieces in order for it to look similar. Okay, it would look something like this when you graph this. And you can always use your graphing calculators to graph this just to look at it and get points if you need help. You're going to have the calculators on the test. So we have y equals plus or minus the square root of x, and we rewrite it as f inverse of x is equal to plus or minus square root of x. So that is the correct answer. And then it says, is the inverse a function? There are two ways to approach this. You can either say no, because the inverse function, well, I guess the inverse itself fails the vertical line test. You will never use the inverse with the horizontal line test. You only use the horizontal line test with the original in the black shown here. Then you do the horizontal line test and see that it fails, and which means the inverse fails. So the inverse fails the vertical line test because that's what actually tests if something's a function. If I draw a vertical line here, it failed it. Or you could say the original function failed the horizontal line test. Those are two options you can pick for your description. You cannot say it, because you have to make sure you're talking about either the inverse or the original. Alright, number 19. Verify that f of g are inverses of each other by showing that they are both equal to x. F of g of x and g of f of x. Again, on the quiz, some of you guys made this too complicated. Always simplify as much as you can. Do not distribute powers unless it's all multiplication or power to a power. So, here's f of g of x. I have this turns into the fifth root of x plus 7, all to the fifth power, minus 7. Now, this would be a case where you can cancel out these powers, because this is basically saying this whole thing, and I'll rewrite it so it's easier to see. This is saying this whole thing is to the 1/5 power. So one term to the 1/5 power, we're now raising it to the 5th power. This is power to a power. You can cancel these out. Minus 7. So what happens is we get x plus 7, because those go away, it's to the first power, and then minus 7, which is just x. Okay, usually they'll simplify very nicely. So if you're not getting it, you probably did something wrong. Don't worry about the powers until you see they cancel. Let's look at the other way. Let's do g of f of x. Okay, let's do g of f of x. So we're sticking f of x into g of x now. So I have the 5th root of x to the 5th minus 7, and then we have the plus 7. Now this is one place where you do not just distribute the 5th power. I saw that on some of the quizzes, is that some people were saying, oh, this is to the 1/5, this is to the 1/5, this is the 1/5. No. What you do first is just cancel these out. They go away. You have a minus 7 and a plus 7. So we end up with the 5th root of x to the 5th. Well, that simplifies to x. You can simplify that. And so therefore, they are inverses. So yes, inverses. Okay, so now I did the 4 that people asked about. I'm going to just pick random ones. Let's do 1 or 2 of these state the domain and stuff up here. Let's do 14. A lot of people asked about 14. So f of x times g of x. So we have 12 x to the 3/4 times 7 x to the 3/4 minus 2. And again, when you're doing that, this is the whole function. Now we multiply that in. So 7 times 12 is 84. When you multiply the x's, you add the exponents. So I'm multiplying this times this. We add the exponents. So we have x to the 6/4. And then minus 12 times 2 is 24, x to the 3/4. And the last thing you do is just simplify your exponents. So we get 84. One of the x's come out. By the way, we can make this 3/2 if we want. One of the x's come out, and we're left with the square root of x minus 24 cubed root of x to the fourth root of x cubed. And again, this is acceptable. I know you guys are saying, well, why can you have a fourth root here and a square root here? When we're dealing with subtraction, we're not going to be able to combine these anyway because they're different terms. It's okay to break it down. If you leave them so they have the same nth root, the same index, then you'll also be fine. The domain restrictions for this, since there's no division happening, since all we have is the x under the square root or the fourth root, our domain is all values for x such that x is greater than or equal to 0. Okay, let's do another one. I have 1 or 2 minutes left. Solving these equations. This one over here, number 11. I don't think this is on tomorrow's part. A lot more of this stuff is on tomorrow's part up here. Just simplifying the exponents and going back to worksheet 1. But again, do not square this yet. You need to get the square root isolated, so move that over. X minus 5 is equal to the square root of x minus 3. So I square root, or I take the raise everything to the second power because I have a square root over here, and that just cancels out the square root. So, and here's our friend on the left again. We have to FOIL. We cannot just say x squared plus 25. That's an automatic some points off. So x squared minus 10x plus 25 is how you would FOIL that. Equals x minus 3. Add the 3 minus the x. You get x squared minus 11x plus 28 is equal to 0. This is 7 and 4. So x minus 7, x minus 4 will give me those numbers, which means that x equals 7, x equals 4. Well, let's take a look and make sure that's the case. Let's go back to the original. When I plug 7 in, I get 7 is equal to the square root of 7 minus 3 plus 5. So 7 minus 3 is 4. 4 plus square root of 4 is 2. 2 plus 5 is 7. So that one works. So yes for 7. Check number 4. 4 is equal to the square root of 4 minus 3 plus 5. Well, 4 minus 3 is 1. Square root of 1 is 1. So does 4 equal 1 plus 5? No, it does not. 4 does not equal 6. So this one doesn't work. And you say no. So then when we write this in our set notation, we have our bracket for this one is 7. And our extraneous solution is 4. Now remember, if all you get is an extraneous solution, you say no solution, and then you give your extraneous solution. Alright, well, it looks like it's running out of time. This is one where you can distribute the exponent real fast, number 2, but you have to put it to both things. So I get 32 to the 1/5, and x to the, this becomes the first power. Well, 32 to the 1/5, we have is 2. And that just turns into 2x. Okay? Alright, well, hope you guys watch this for some of the harder, more difficult problems. And again, come in early in the morning if you need help. Don't leave it till the last second, and then study the stuff that's on tomorrow's test, and hopefully you guys will all do well.